Hi guys, so this video is going to be on compound interest. So compound interest is one of the applications that we can use with exponential and log functions. So I'm going to start by just talking about what compound interest is. So interest is if we put something in a savings account, it's what we earn on it. Or if we borrow a loan, it's what we pay, the extra money we pay in order to have the loan. So simple interest is just calculated by taking the balance of the loan and multiplying it by some percentage. Compound interest, on the other hand, takes any interest that is earned or owed, and it also charges interest on that. So it grows a lot faster. So if it's a savings account, it's good because you're earning interest faster. If it's a loan, it's not so good because it means you're paying out more for the loan over simple interest. But we're going to look at some equations here, some formulas. The first one is A equals P times 1 plus R over N raised to the power of N times T. So we're going to talk about what each part of this is representing. All right, so A here, this is going to be the final amount of whatever if you put some money in the bank and you're earning interest, it's going to be the final amount after a certain amount of time. If you were to borrow a loan, it's the amount you paid finally. Okay, so P is going to be your initial investment. Your initial investment is the money that you put in a savings or the money that you borrowed. This is also sometimes called the principal balance. Okay. This is just a 1 here. R is equal to the percentage, the interest rate in a percent. The interest rate in decimal form. Okay, so if we want to use it in the formula, we're going to need to use it in decimal form. So oftentimes when you hear an interest rate, it's in percentage form. So if it said, for example, that the account accrued 5% interest, we would want to change that to the decimal form, which means take this decimal that's after 5 and move it 2 to the left. So in our formula, we would want to write that as 0.05. Okay, if it were 4%, it would be 0.04. So when we put it in the formula, make sure it's in decimal form. N is going to be the number of times it's compounded, the interest is compounded, or how often they multiply it out and add more interest. So number of times interest is compounded per year. Okay, so for example, if you're reading a problem and it says that it's compounded yearly, then that's just going to be, N is going to equal 1 because yearly happens once per year. If it said weekly, there are 52 weeks in a year, so that would be N equals 52. If it said monthly, monthly happens 12 times a year, so N would be 12. If it said semi-annually or annually, annually means every year, so yearly or annually means kind of the same thing. So semi-annually would mean that N is equal to 2, because that happens twice a year. Quarterly would happen 4 times per year, so N would be equal to 4. If it said daily, if it compounded daily, N would be 365. Okay, so that's just the number of times per year the interest is compounded. And then T is equal to the time that goes by. So if I want to know what my balance is after 5 years, if I'm earning interest, I would put T is equal to 5. So it's the time that passes. Okay, so we're going to look at some examples using this. I will say that there are 2 formulas. So this first one is for interest that compounds N times per year. So if you're reading a story problem and it says the interest compounds a certain number of times per year, could be weekly, monthly, could be any of these, then you're going to use this first formula. If it says that it compounds continually or continuously, then you're going to use a different formula. This means that that interest is being added all the time. So this would be A equals P, and then we're going to have E raised to the power of R times T. Now A is the same A, P is the same P, R is the same R, and T is the same T. We have this E in here, and this E is not a variable. This E is the base of natural log. It equals about 2.72. But your calculator has a key. It should be just above the ln key. It has, like, here's the ln key on your calculator. It has an E key above it that is raised to the x power. If you want to access E, you'll just hit second and then natural log, and it will pull up E. So that's the E that you want here. It's not a variable that you're going to plug something into. It's equal to a number, and we want to not round it off and use it as 2.72, but we want to use the E in our calculator when we're using this. Okay. So let's go ahead and do a few examples. So I'm going to clear this off, and I'm going to write the equations back here. So if it's compounded n times per year, we'll use this one. And if it's compounded continuously or continually, we'll use this one. Okay. So let's say that Sylvia, I don't know why that's the first name that came to my mind. I don't even know anyone named Sylvia, but let's say that Sylvia invests $2,000 into a savings account, and it earns, let's say, 4% interest, compounded monthly. How much money how much will she have after 5 years? Okay, so let's see what would happen if you had $2,000 laying around. You put it in a savings account that has a compound interest of 4%, compounded monthly. So here, A is going to be the amount we're looking for, right? Our P is 2,000. Because that's the initial investment. That's how much she's putting in. So I'll put 2,000 out front of our parentheses. We have 1 plus. Then our interest rate is 4%, which means we want to put R as equal to 0.04. We want to change that to decimal form. Over N, which is the time that passes, so that would be here. Raised to N, so 5 times N. So it's compounded monthly, which means N equals 12. Oops, I put the 5 in the wrong place, didn't I? So the interest rate is 0.04. We want to put that over N, and N is the 12, and then we want to raise it to the power of N times T. So 12 times 5. So there's our formula. So now we can just put this in our calculator. We do have to be careful here with order of operations, but you should be able to just put that right in your calculator as you see it, as long as you put the parentheses here, and as long as you make sure that these both are in the exponent. So if your calculator has that function where you can see that these are both in the exponent, you don't need to worry about it. If it doesn't, you may need to put parentheses around those as well. So let's go ahead and calculate this. So I'm going to put this in my calculator quickly. And it may not be a bad idea for you to grab a calculator and try this on your own before you, or just to make sure you get the same number as me, because we don't want to make calculator errors here. So 2,441 and 99 cents. Okay, so after 5 years, she would have earned $441. All right, let's try another example. All right, so let's see, how much money did you invest initially if you currently have $8,000 in savings, that earned 4% interest. It's going to be 4% again, I guess. Compounded weekly for 3 years. So what was our initial investment if we currently have $8,000 and we our percentage was 4%, our interest rate was 4% compounded weekly for 3 years. So what we want to do here is we want to decide which ones of our variables we have. So we know the final amount is $8,000, so that's A this time. We're looking for P, we're looking for the initial investment. We know our interest rate is again 0.04, so that'd be R. It's compounded weekly, and there's 52 weeks in a year, so that'd be N. And then T is equal to 3 years. So I would put 8,000 equals P, that's the one we're looking for, we don't know that one yet, times 1 plus R, which is 0.04, over N, which is 52, and we raise that to N times T, so 52 times 3. So on this one, I'm trying to solve for P, and since P is multiplied by all of this, in order to find P here, I would need to divide the 8,000 by all of this. 1 plus 0.04 over 52, raised to the power of 52 times 3. Again, be careful with your order of operations. Grab a calculator and try it and see if you get the same thing as me so that we make sure we're not making calculator errors. Alright, so when I put that in my calculator, I got 7,095 and 69 cents. Okay, so it looks like just over $900 is what she made in that, or that you would have made, I guess it was you, over that 3 years. Okay, all right, so we do need to look at one other type of problem here. So again, let's write down our formulas. So we have A equals P times 1 plus R over N to the NT. And then we have A equals P E R T. So let's say we have, trying to find a good example on my paper here. If you have $3,200 and you invest it at 3%, compounded continually, what is the balance after I can't spell, 6 years? Okay, so our initial investment, P, is $3,200. Our interest rate is 0.03. It's compounded continually, which means I'm going to be using that formula. And the balance after 6 years is what we're looking for. So we're looking for A here. So P is 3,200, so I'll put that in front. Oops, I didn't need a parenthesis. I just have E times E raised to the R, which is 0.03 times T, and T was 6. So A equals 3,200 times E raised to the 6 times 0.03 power. Now, in your calculator, you're going to hit the second and then the natural log key to get this key. So I would do 3,200 times, and then you hit this second and the natural log to get the E in there, and then you just do the 6 times 0.03 in the exponent. So again, try it on your calculator. I'm going to pause this and do it on mine. And that gives me 3831.09. Actually, it's going to round up to 10. So 3831.10. Okay. All right, so lastly, we just need to look at what happens when we're looking for either the interest rate or the time, because that's going to be in our exponent on some of these. So let's say that I wanted to find how long would it take to double $2,000 if the interest rate is 5.5% and interest is compounded monthly. So we're looking for T. We're trying to find T. It's compounded, this one right here, because it's compounded monthly, right? So let's find our variables here. Our initial investment is the $2,000. A is going to be double that. So it's going to be $4,000. The interest rate is 5.5, so R is equal to 0.055. And the interest rate is compounded monthly, so N equals 12. So T is what we're going to be solving for here. So 4,000 is our final amount, equals 2,000, which is our initial investment, times 1 plus interest rate, which is 0.055, over N, which is 12, raised to 12 times N. No, that is N. 12 times T. So T is what we're trying to solve for. In this case, because T is what we're trying to solve for, and it's in the exponent, the first thing I need to do is get this section right here all by itself on one side. So to do that, since this is multiplied by 2,000, I'm going to divide both sides of my equation by 2,000. So 4,000 divided by 2,000 is just 2. And on this side, those cancel, so I just have the 1 plus 0.055 over 12 raised to the power of 12t. Now, because what I'm looking for is up in the exponent, in order to get it out, I'm going to have to change this to log form in order to get that out of the exponent. So remember, log the base. So let's actually calculate what the base is. So this I can calculate, right? 1 plus 0.055, 1 plus 0.055 divided by 12 is equal to 1.0045. So I could write this as 2 equals 1.004, and it's 5/8, so I'm going to round it up to 4/6. So that's just this part right here. 1 plus that equals this. And that would be raised to the 12t. So now this right here I'm going to change to log form. So remember, this base number would be 1.0046. That would be the little number down here. And then of 2 equals the exponent, 12t. So this right here, I can put that in my calculator as log 2 divided by log 1.0046. And that's going to equal 12t. So I'm going to go ahead and do that. So I'm just taking log 2. I'm closing the parenthesis, and then I'm dividing by log 1.0046 and closing the parenthesis. Hit enter. And this side over here is 151.03. And that equals 12t. So now I can just divide that by 12. And then I'll know how long it would take to double the $2,000. So 151.03 divided by 12 is equal to 12. I'm going to round it up to 12.6. So it would take 12.6 years to double that $2,000. Okay. So anytime you're looking for one of the things that's up in the exponent, you first need to get the term that's raised to the exponent by itself on one side, and then you need to change to log form. Okay. So go ahead and give some of these a try, and if you have questions, let me know.